Hello, we are going to start off with this problem. If you want to give yourself a minute to do it, pause the video, go ahead. Otherwise, I will do it right now. And this is the equation you're going to want to start with. It's the equation for the voltage across the capacitor. And this constant here, R times C, is known as the time constant, as we talked about already. And that, when that is equal to T, or when T is equal to RC, we know that V is going to be the initial voltage times e to the minus 1, which is about equal to 37% of V. It's a really easy calculation. That's why this is so interesting to us. You'll see what happens when we don't have that calculation. When we pick some other value for RC when T is not RC. You just have to do a little bit more work. But this is the case where you just don't have to do that much work. You can say, oh, okay, when I drop from 10 volts to 3.67 volts, that's a 37% drop. So that means that 10 seconds, which is the time at which that took, that's equal to R times C. And so I'll say 10 equals R times C. And if C equals 100 microfarads, that's equal, by the way, to 100 times 10 to the minus 6 farads. Then we can calculate R. We can say, well, R is equal to 10 divided by C. And that's equal to 10 divided by 100 times 10 to the minus 6th. That's equal to 10.1 times 10 to the 6th, or 10 to the 5th ohms, which is 100 kiloohms. Hopefully that looks familiar to you because that's what you saw in lab. So that would be the value of the resistor, and that's how we'd calculate it. Okay, a few announcements. One is that this week the quiz will be on capacitors, finding the charge and voltage associated with them, and what to do when you have capacitors in parallel and in series, calculating the equivalent capacitance in those cases. Unlike the last quiz, this one will be confined to 30 minutes. The last one was intended to, but you had all unlimited time to do it. And the other point I wanted to raise about the quiz is if you get a given question wrong on the first try, they're all multiple choice questions. You'll have multiple tries to get them, and the points that you receive will be reduced according to the number of times you try a given problem. So if it's the fourth try that you get a problem right, you won't get any points for it because that's the last choice. So the fewer times it takes you to solve a problem, the more points you'll get. But you do get partial credit for each problem. Lab this week is going to be on RC circuits. You can start at any time you want. The videos are posted. And homework 5 is due tonight. And we have a guest, or at least due Tuesday night, I should say, depends when you watch this video. And on Tuesday, during regular class time, we have a guest presenter. And I'll also take questions following her presentation. Here's a clicker question, and if we had clickers right now, I'd have you do it. But if you want to pause the video, go ahead and think about this question. And the question is, what will happen to the time it takes for the voltage across a capacitor to decay to 37% of its initial value, or for any percent of its initial value, if the value of the capacitor decreases? So you have three choices there. And the answer is that if the value of the capacitor decreases, the time will decrease because the time constant of the capacitor, R times C, is going to be smaller, and that's time in seconds, as we'll see shortly. Another example of a capacitor that I wanted to give you, this one isn't as clean. This one is going to involve a percentage other than 37%, which will show you why I like 37% so much, even though 10% might sound a little bit cleaner than 37%. But let's say we have the same resistors we used in lab, or that we will use in lab, if you haven't done the lab yet. A 100 kilo ohm resistor and a 100 microfarad capacitor. And the question is, how long will it take for the voltage to drop to 10% of the capacitor's initial voltage. So whether you start at 10 volts or 20 volts, it'll take the same amount of time to get to 10%, which is what's true about the exponential function. And so I'm going to write the equation down again that I wrote a few minutes ago. There's the equation. And so what I have here is 10%. I could say, okay, 10% means V of t. I'm going to divide both sides by V0. V of t divided by V0 is equal to 0.1. That's 10%. So whether this is 1 volt and that's 10 volts, or whether this is 2 volts and that's 20 volts, that is going to be the relationship that we're going to use. Decided I would do the video on a larger surface than I had on the previous one, so I'm going to redo this problem. Here's the original problem. V of t is equal to V0 e to the minus t over RC. And I'm interested in finding out in this problem here. I am here. How long will it take for voltage to drop to 10% of initial value? All right, so another way to think about that is if V of 0 starts out at 10 volts, V of t would be 1 volt. If V0 started out at 20 volts initially, then V of t would be 2 volts. That's what 10% means. So I could rewrite that, divide both sides by V0, and you get V of t divided by V0 equals e to the minus t over RC. Okay, so that's the equation you have. And this, by problem statement, is 0.1 or 10%. That's 0.1. Okay, now R times C in this problem, R is 100 kilo ohms, and C is 10 microfarads. I'm going to rewrite that in ohms and farads. So 100 kilo ohms is 100,000 ohms, and C is 10 times 10 to the minus 6 farads. I have to put that in the basic units, ohms, farads, to do any conversion or calculations with these numbers. So this is 10 to the 5th, and this one is 10 to the minus 5th, because 10 times 10 to the minus 6th is 10 to the minus 5th. And that's ohms, that's farads. When I multiply ohms and farads, we're going to see in a moment, in a couple slides, that that's seconds, which is kind of amazing. But 10 to the 5th times 10 to the minus 5th is simply 1 second. All right, so that's what RC is equal to. So I could rewrite this whole equation as 0.1 equals e to the minus t divided by 1, which is equal to e to the minus t. Now, if I take the natural logarithm of both sides, because the natural logarithm of e to the x is equal to x, if I take the natural logarithm of e to the minus t, I get minus t. If I take the natural logarithm of 0.1, I'll do that on Excel, I'll get what that's equal to. So if I go to Excel, I have it right ready here to take a look at that. Slide that over. So the natural logarithm of 0.1, press return, negative 2.3. So I could say this here is equal to negative 2.3. That's equal to negative t. Actually, you can see this. I think you can see that, I hope. So therefore, t is equal to 2.3 seconds. That's how long it'll take for this combination of resistor and capacitor to drop to 10% of its initial value, whatever its initial value is. It's going to take 2.3 seconds.